Right, so again, good evening, everyone. So again, my presentation is based on, it's entitled The Optimal Stopping Criteria for Customer Contact Strategy in Targeted Marketing, right? This was published in CCIS, volume 1623, and I think it got accepted not too long ago, probably July of this year, right? Next slide. So just a kind of breakdown what's going to happen today. Introduction, we're going to just briefly go over some related work. We're going to get into our process of how we did things, have a visual illustration of how it was done. There's a typo here with related work, but ignore that. Then we're going to go to experiments and then wrap up with a very short conclusion. Okay, so introduction, right? Marketing, as we know, is a very essential aspect of modern business, right? So companies, institutions, they have a lot of products that they want to market to their customers. They have a lot of types of customers. And to further complicate matters, there are a lot of different contact mediums you can use to contact these customers. So you must be a bit wary of how these contacts are made. So again, you might envision that, repeated contacts to a customer, whether it be emails, phone calls, or what have you, might potentially irritate the customer. So what we are trying to do here is determine effectively the optimal number of contacts that we can make to our customer just before the point of irritating them, right? Again, irritating them might have some undesirable effects. In one case, a very extreme case, they might actually leave the business, and go to a competing business, sorry. In a mild case, they might actually stay, but they'll just be annoyed at any further calls. So that is what we're going to try to tackle today with this problem. So again, we conducted our own research into this problem of improving the success of marketing campaigns. Right, so again, we did some prior work on this, and this was already published previously. You can find the publication on the lab.tt website, and it was presented at the 10th International Conference on Operations, Research, and Enterprise Systems in Austria, a virtual conference. Okay, so just to kind of get an idea of the related work being done so far. So there are pretty much 4 things we kind of discovered when looking at related work to this problem. So the first thing to the left there is that it was framed as a binary classification problem. So either yes or no, you make the contact and you train different models, and you pick the model with the best success, right? Measuring customer lifetime value. So one author, they used sliding windows to compute lifetime value based on the projected future interaction of the customer, right? Another one was dynamic programming formulation. So this pretty much focused on assigning multiple messages to contact segments and doing simulations in that regard. And our old approach I have there to the right, it's where we effectively derived our own customer segments, and based on that approach, we contacted these segments in a particular fashion to maximize the success, right? So problems with these related works, right? So the first one is that being it framed as a binary classification problem, we don't really get to know how much contacts to make to the customer. So we can potentially end up irritating the customer, right? Measuring customer lifetime value. I think with this one, as well as the dynamic programming formulation, there weren't really simulations provided to replicate the results. So that was a bit difficult just to kind of get an idea of the performance. And in terms of the dynamic programming formulation, again, this one assumes that you know your customer segments. So our next problem there, right? In terms of our old approach, we can't really control how we form the customer segments. And just to note there, over 65% of our customer segments with the initial approach had had no customers assigned. Okay, so moving on a bit, right? So pretty much our process, right? Again, we're going to assume that we have a marketing campaign, simple, and it's going to be based on making telephone calls to customers in a bank, right? We have a limited number of calls. It's a finite resource, right? And based on historical data, historical contact data with previous campaigns or whatever, we could try to segment this customer base, right? So now, given a new customer, we could try to determine which customer segment they belong to and how many times they should be contacted. And if we strategically prioritize calling off the customers, we could try to maximize the success over the calls being made over time, right? So moving on again here, in terms of a brief illustration, this kind of briefly or in a nutshell covers the approach. So if you look at the diagram here, again, this kind of over here is the limited batch of calls that we could make. And the boxes here to the left, to the right, to the bottom denote different customer segments. And let's just assume that for the one to the right, we determine that one call maximum is best for these type of customers. They get irritated pretty quick. We make one call and stop. If they don't accept the product, we just move on. For the second one to the middle here, they're a bit more lenient. They would accept 2 calls, but beyond that, they would just kind of get angry or mad. And the third one, again, they're a bit more lenient as well than the second segment, so they accept more calls. So this was pretty much the gist of what we were trying to do, right? Experiments now. So again, a lot of the work was described, in the journal paper, it was described in a lot of detail, so you can check out the paper to see more. But I'll try and summarize the experiments for you very quickly, right? So effectively, there's a first approach that we had. It's called a baseline approach. Now, with this approach, it effectively was just randomly contacting customers, of the entire data set and keeping a track of the successes, made versus the number of calls we made, right? Just to mention as well, we use 5-fold cross-validation and an 80-20 train test split for this, right? The second method that I'll just briefly go over here is the greedy customer segment approach, right? So this is referring to the first segmentation approach in the old paper. And what it does, it just effectively is a very naive way of grouping customers together based on their features. So if per se you're married and you're less than 50, you win a segment. If you're single and you're greater than 60, you win a next segment, and that's how that approach was. And what we did, when we identified these segments, we then computed the success per call rate based on previous history for the segment, and then given some new customers now, if they were assigned to particular segments, based on the success rate of the segment, the historical success rate, we would assign the calls in a prioritized order there, right? The GA approach, this approach is basically a bit of an optimization to the GC approach, where we try to make a minor optimization of applying the convex hull to the number of calls being made. As you can see, it didn't result in much increase in performance because we didn't have much data for this part actually, right? So UB denotes the upper bound for the problem, and this serves as a benchmark for us. So this says, okay, if I know exactly how much times to call this customer, I can note my successes on calls over time. So that's defined by this, this extremely steep curve here to the top here, right? So GC star and GA star pretty much is the new approach, and effectively it's pretty much the same as GA and GC from the old approach, but we have used a clustering algorithm in this case now to find the optimal number of clusters. For purposes of experimentation, we ran the k-means algorithm from, I think, 1 to 500 clusters. And I think the best performance we got was around cluster number 175, right? So to the point here now, we're gonna notice that we have significant increases in results with GC star and GA star. So this is the 2 darker lines here to the top, denoting GC and GA star. And in terms of an average improvement, we got an improvement of 57.4 and 56.8 % respectively over the corresponding baseline approaches. And just a note, again, as I mentioned before, we made the same number of calls for all approaches. So the criteria was the same, we just varied the approach. Furthermore, explanation into the experimentation. Again, for GA star, the reason why it didn't perform better by applying the convex hull was that it failed to compute, again, due to lack of data for the segments. And in terms of how the experiments were run, we ran it on a Titan GPU. We used the Rapids library for experimentation. And this actually gave us a pretty nice speed up. We had a speed up of over 14 times, where we saw that the CPU-based approach took 605 minutes, and Rapids took a little less than 3/4 of an hour, I should say. So we got a lot of nice speed up with the Rapids library. And again, it's pretty intuitive to use. It's pretty easy. And it's like literally using sklearn at this point, right? Yeah, and that pretty much brings me to the end of the presentation here. I know it's a bit short, but I could open up the floor for any questions at this point. So yeah, feel free.
Yeah, thanks, Shiva. Yeah, I know many of you might, there's stuff in there. There's a lot of stuff in there, a lot of mathematics that, we didn't come into play, when you talk about convex hull, etc. But it's an interesting paper. So, if you get a chance, have a look at it. As well as Adidev's paper, by the way. So, the one of the things we've been looking at recently is instead of using clustering, using a slightly different approach, which Chris and Kevin are doing some stuff with that as well. So we potentially could apply that here as well. So maybe that's something we could discuss in the future, Shiva.
Yeah, sure.
So yeah, I'm going to open it up for questions. Any questions from anybody?
Feel free.
Yeah. Hey, Shiva. So something I'm working on right now. You could tell me a little bit more about how you do the customer lifetime value thing.
Okay, so I didn't really investigate that too much with the last paper. I just kind of skimmed it through. I think if you check out my paper, you could see the reference and check out that paper in depth as to how they do customer lifetime value. But I think what they try to do is that they try to predict, okay, over the lifetime of the customer, over the years, they might bring in this number of revenue or this certain value. So obviously, customers with higher expectation would be contacted first because they have more money of some sort.
Okay, wait, you can remember if it was like a recommender system or something, classifier or something? Yeah?
No, I really can't remember, sorry.
No problem. Thanks, man. But good work, though. Interesting stuff.
Thanks. See, Nick has a question.
Hi, Shiva. Nice presentation. I missed a part of it because ironically I got a call. But can you just tell me what exactly the characteristics you look at to determine this criteria of the customer?
Okay, so I actually have a link here to the UCI repository where the data set is housed. So I can share the link in the chat. You can take a look at it, but effectively I could zoom in some more here. And you'll see that there's some information on the customer. So it's more pretty much demographic data. So their age, their job, marital status, education level, whether they're defaulted on a previous loan, and so on. There's also information regarding the previous contact of the campaign. So we use that as well. But I think beyond here with like social and economic context attributes, they were only, I think, by quarter. So we couldn't really take them into consideration because I think this data only ranged across less than 2 years or a little over 2 years. So it didn't have much variation there for the model. So again, we pretty much use the k-means and we pretty much clustered based on the demographic data. And again, from that demographic data, it formed the clusters and assigned customers to particular clusters. And again, we use that now to determine the success rate of each cluster. And that would prioritize how we make calls when a customer gets assigned to a segment in an actual scenario. Yeah.
Okay. I have a feeling that age would play a large role. Did you see that?
I think upon analysis,
like was it, yeah, that determine your clusters?
did we have that in the paper? Actually, I don't think we actually explored the feature importance in the k-means. But I think in the previous paper, we did some initial exploration into feature importance and, the success rate ratios, like say if you were older than 50 or younger than 50, if you were single or married. And I think age did play a factor, marital status as well, and education were most important in that regard to determine the clustering. Yeah.
All right. Okay. Thank you.
No problem.
Anybody else? So
Always so articulate, Shiva.
Sure.
was that
I was
sorry?
saying you're always so articulate, Shiva.
Oh.
I'll harass you later.
By the way, so this is an example of using a publicly available data set for a different purpose that it was provided for. So for this UCI data set, I guess the question was different to what we were looking at. So we use the data, but use it for a different problem completely.
Yeah, it's binary classification. Do you call or do you not call the customer? And we realized that you know, it wasn't really a good way of determining how successful were you in, you know, making the contacts as well as the irritation level of the customer. So this approach takes that into account.
Yeah, and actually, recently I was talking to Stefan Hosein, and some of you may not know this. He now works for Spotify, and he was talking about the problem he's working on, and it's related.
Okay.
How to provide advertisements, etc., without annoying people, etc. So yeah, interesting problem.
Well, Stefan move again.
Yeah, yeah. Spotify.
Question on this. I like the idea how you're using like data sets for other problems. I was curious if in the courses you'll do something like that for assignments. Give students the chance to kind of explore and think of come up with ideas with data sets.
Well, at least I can talk for my class. I leave it up to them. I tell them to find a data set and find something to do with it. So, you know, in most cases, they end up doing something similar to what the data set was provided for. But yeah, I encourage them to explore different things. But, you know, it's not always easy to find. You need to understand the business and what objectives the business may have to derive a problem. And it also has to have the data that you need to solve that problem. So, but yeah, I try to encourage them to explore using data for different things.
Okay, cool, thanks.